Hi guys. So, hey, I made a mistake with our first quiz. I thought we went lesson 1-1 through lesson 2-2, but we did wrap up with lesson 2-3 where I taught the negative exponents with scientific notation. So, we're going to pick up today and I'm going to teach you guys. We're going to go through lesson 2-4. So, I did send a note out to your family and I did encourage them to get you guys a notebook. I don't know if you guys recall, but one of the best things that you could do when you were doing your math was to get a math notebook and you took notes every time your teacher wrote problems or examples and taught things on a whiteboard. You were writing those things down as well. If you guys have this notebook handy, that's going to help you guys so much on any tests or any quizzes. So I would like you guys to really, if you haven't done so, keep track of what we're learning. We will do cumulative assessments. So we're looking at like over the course of a semester, we're going to go back and talk about this. Now, I guarantee you guys, come January, you're not going to remember what we were doing in October. So I would encourage you guys to really have this written down as a resource for you to go back and for you to be able to refer to later on in the year. So we're going to move on. We're moving on into, oh, my marker's not looking that great. So I'm going to choose a new one. We'll move over to purple. So we're going to look at lesson 2-4. So we're now at lesson 2-4. 2-3, you guys should have had notes over, and I apologize that my thing said 2-2. 2-3 was scientific notation with negative numbers. So what we're actually going to be learning in this lesson is we're going to be doing some operations. So when I say operations, I'm talking about adding, subtracting, multiplying, or dividing. So you guys are doing operations. All of those, we're going to talk about adding and subtracting, multiplying, dividing with scientific notation. Now, I decided that I don't want to take this entirely through every operation. We're going to practice. I'm going to split this up. So this week, what we're going to do is on Monday, when you guys are looking at this lesson, we're going to be doing adding and subtracting. So we're going to be just looking at those two operations to begin with. So we're just focusing on the adding and subtracting to begin with. We will go through and we will look at multiply and divide, and we'll do that on Thursday. So I'm going to split it out so that it doesn't get super confusing for you guys. Today we should be looking at October 19th. So October 19th, 2020, I'm just going to be covering adding and subtracting with you guys. That's it. So that's all we're going to focus on. Our homework is going to cover addition and subtraction with scientific notation, and then I'll expand that into multiplication and division on Thursday, and then we'll probably do a cumulative where it'll be a mixture, and you really got to pay attention to the small details, like are you adding, are you subtracting, are you multiplying, or are you dividing? So today's focusing solely on adding and subtracting when we are given numbers that are written in scientific notation. So I'm going to give you guys a couple examples and walk you through what the process is and how we do that, okay? So we'll do both addition and we'll do subtraction. To begin with, I'm going to show you guys addition. And here's what's really cool is when you guys are doing both addition and subtraction, you're following the same procedure. You're following the same rules. So what we're going to do is I'm going to give you guys an example, and we're going to I'm going to give you guys the steps that we follow to get our solution. So our example is we're going to take 4.2 times 10 to the 6th plus 2.25 times 10 to the 5th plus 2.8 times 10 to the 6th. All right, so notice that I got like 3 numbers that are written in scientific notation here. I have remember scientific notation is some number, and that number has to lie between 1 and 9. So you don't have a 0 ever here. You always got like a single digit that's sitting there. So 4.2 times 10 to the 6th. It's always multiplied by 10 to some power. So that's my first one. Here's my second one, and here's my third one. And notice that they're all separated by these additions. So I'm taking like this first scientific notation, adding the second, and then adding the third. So I'm looking at grouping these 4.2 times 10 to the 6 plus 2.25 times 10 to the 5th plus 2.8 times 10 to the 6th. All right, so what your procedure is the first thing you want to do is you want to look at these powers of 10. So I have 10 to the 6th, 10 to the 5th, 10 to the 6th. These all have to be the same. So if you guys notice, I got 10 to the 6th, I got 10 to the 6th, and I got 10 to the 5th. Ooh. This 10 to the 5th is going to mess up our addition here. We want this one to be exactly like these other ones. And what my strategy is instead of like changing 2, instead of looking at this and going like, I can change that to a 10 to the 5th, I could change this to a 10 to the 5th. Much easier for me to look at 1. This is just a 10 to the 5th right here, and I can make this one a 10 to the 6th. I can make it a 10 to the 6th by just hopping that decimal point. Remember that all we're doing when we're changing that power is we're just hopping the decimal point. So I'm going to hop that decimal point. I'm going to put it, instead of being between the 2 and the 2, I'm going to put it in front of both 2's. So I'm going to have 0.225 times 10 to the 6th. These are exactly the same thing. Remember, if I move it back here, you drop down that decimal point. If we're going to move to the right, it's going to go less. If you're going to go to the left, it's going to get higher. So I'm going to move that over. I'm going to make that 0.225 times 10 to the 6th. Then this one is still going to say, I like this one. This one's in nice form for me. This is still 4.2 times 10 to the 6th. And then this one's in nice form for me too. This 2.8 times 10 to the 6th. These are all really done well for me. So now I have 10 to the 6th, 10 to the 6th, 10 to the 6th. I got it all the way across the board. So now the addition becomes pretty simple. What you're going to do is you're going to take the numbers that are in front of that base of 10 to the 6th, and we're actually going to add those all up. So don't forget that when you guys are adding up decimals that we have to line those decimal points up. So I got 4.2, I have 0.225, and then I have 2.8. And I'm going to line those all up, and I'm going to do this addition. I'm going to add everything all up. Now, I would encourage you guys are welcome to fill these placeholders in with zeros if you guys would like. That will help keep everything lined up so you don't lose a digit somewhere in there and you end up being off. So I got 0 plus 5 plus 0, so that's going to give me 5. 0 plus 2 plus 0 is going to give me 2. I have 2 plus 2, which is 4. 4 plus 8, which is going to give me 12. And remember, bring that 1 up because that's a 12. That 10 is going to carry over into the next place value. So then I'm going to do 4 plus 1 is 5, and then 5 plus 2 is going to give me 7. So my overall answer for all these numbers in front of the power of 10 is 7.225. Now the last thing, this is why we want to change those so that we have the same exact power of 10. The last thing we're going to do is to write this in scientific notation by bringing that times 10 to the 6th power. This was 10 to the 6th, 10 to the 6th, 10 to the 6th, so my answer is going to be 10 to the 6th. If they all have the same power of 10 behind it, you're just going to add that number in front all together, and then you're going to bring down that same power to the 6th. So what I ended, or same power of 10. So my overall answer for this one, I should come up with, this is all going to equal 7.225 times 10 to the 6th power. There's my solution for that one. So there's an example of addition. My procedure again is to make sure that the powers are the same. The power of 10s are the same. And all you got to do is just add up the numbers in front and keep that power the same in the solution. Pretty simple procedure. Tricky part might be actually like converting everything over so that you have the same power of 10. Okay, so I'm going to do another example, but this time I'm going to switch it up and I'm going to switch it to subtraction instead of addition. So we're going to move over and we're going to look at what's it going to look like if we actually have the number and the numbers and they're all lined up and we're actually subtracting them instead of adding them together. So here's an example I'm pulling out of your guys' book. So I'm going to take 8.5, and this is times 10 to the 3rd power minus 5.3 times 10 to the 3rd power minus 1.0 times 10 to the 2nd power. So this time, notice that the only difference here is that we're actually subtracting. This is like a subtract, and a subtract. We still have a number times 10 to some power, another number times 10 to some power, and then another number times 10 to some power. Now with subtraction is going to follow the exact same rules as addition. So what I'm doing is I'm going to be looking at these powers of 10, and I want these all to be the same. So this is 10 to the third power. This is 10 to the third power. This is the weird guy. That's 10 to the second power. Now that 10 to the second power is not going to work, but I can make it 10 to the third power. What I'm going to do is I'm going to take that decimal point. I'm just going to hop it over. We're going to hop over to the left to make that a 10 to the third power, to add a 1 to that. So this is going to come down. It's going to become 0.1 times 10 to the third power. Bring everything else down. So I got 8.5 times 10 to the third minus 5.3 times 10 to the third. And I got this minus. All I'm doing is just hopping those decimal points to make this so that they're all lined up. They're all nice and even and neat for me, so that I got the same base power of 10. All right, so now I'm following the same procedure that we did with addition. I'm going to come and I'm going to take this and I'm going to look at these numbers in the front. So I have 8.5. I'm going to come over here and I'm going to go 8.5. I'm going to subtract 5.3. And then after I just subtract the 5.3, I can't forget I'm going to subtract 0.1. So 5 minus 3 is going to give me 2. 8 minus 5 is going to give me 3. Now I'm looking at 3.2 minus a 0.1. 2 minus 1 is a 1. Now I'm going to bring down that 3. So once I've done all those subtractions, I cut all that subtraction. I do 8.5 minus 5.3 minus the 0.1. I get 3.1. So my answer for this one, when I get all done, is I'm going to bring down that 3.1. I'm going to go times 10. And remember, this is all to the third power. These were all converted over times 10 to the third power. So you keep that base 10 and that exponent the same in your solution that you converted everything to. So you're going to try to make these powers of 10 all the same. You're going to do either the subtraction or the addition with the numbers in the front accordingly. And then you're going to bring down that exact same power down below in your solution. And always make sure that your solution only has one digit in front of that decimal point. If for some reason, like my addition would have came up and let's say that it would have given me like 2 digits in front, like it would have given me 25.1, I would have gotten 25.1. I would have had to hop that decimal point over and I would have to convert this to a different power over here. It's proper scientific notation only has one digit in front of that decimal point. All right, so there's an example of that one. Maybe I will do another one just to make sure you guys have plenty of examples. Because I would say that the feedback that I got from you guys was just that we didn't do enough examples. So I'm going to make sure that I cover quite a few of these so that you guys got plenty of options to like see these problems and for you guys to be able to see it worked out several different ways. So I'm going to do another example off of the worksheet that's out of your guys' book. This one says 1.25 times 10 to the second power plus 0.5 times 10 to the second power plus 3.25 times 10 to the second power. Oh, this one was nice. This is really actually where I probably should have started. This one's a nice one because if you guys look, this is 10 to the second power, 10 to the second power, 10 to the second power. That's kind of nice. I didn't have to do any sort of hopping at all, like with my numbers in front, so that these are all end up being the same power of 10. I actually am adding all of these, so you can see that you're adding the numbers in the front. So I'm going to take 1.25. I'm going to add 0.5 to that, and then I'm going to add 3.25. And now what's great about addition is I can just line up those decimal points, and I can add these all together. I can line them all up nice and neat, and just get an answer for when I add all these decimals up. So remember, we always start at the right. So 5 plus 0 plus 5 is going to give me 10. I'm going to do 1 plus 2, which is 3. 3 plus 5 is 8. 8 plus 2 is 10. Now I'm going to get 3 plus 1, which is 4, plus 1, which is 5. So I get this like 5.00. Now you can write those zeros, but you don't have to if you guys don't want to. That's the same thing as just saying a 5. So I got 5 times 10 to the second power. That's going to be my answer for this one because every single one of these was already converted over into 10 to the second power. So what we're going to do is we're going to add the beginning pieces, keep that 10, that base 10 the same all the way across. All right, so there's an example with addition. And then there's one more. Basically, you guys, what I'm doing is problems 1 through 4 on the worksheet that would have been in your guys' textbook. So we're going to do 6.2 times 10 to the 5th minus 2.6 times 10 to the 4th minus 1.9 times 10 to the second. Oh, okay, so this is the fourth problem, and this one got a little bit harder. I want you guys to notice that I'm doing subtraction, right? All the way across, I'm subtracting. So this is a subtraction problem. When you subtract, these powers of 10 have to be the same. So I have 10 to the 5th, 10 to the 4th, and 10 to the 2nd. None of those two are the same. I've shown you other examples where 2 were the same, so all I do is convert 1. In this case, since they're not all the same, I'm looking at keeping 1 the same, and then 2 I'm going to have to change to match that. I don't know. My general preference is to usually keep the biggest one, but you guys can work. I don't care which one you choose to switch, as long as your final solution is in proper scientific notation. So it doesn't matter. You guys can choose to convert these all to like 10 to the second power. You can convert them 10 to the 4th power. You can convert them 10 to the 5th power. I don't care which one you choose. You just have to make sure you only have one digit in front of the decimal point at the end, and it's times 10 to some power. So you got to make sure that you can take it out of whatever form you got and get it in proper scientific notation. So what I'm going to actually do is I'm just going to do this one. I'm going to pick and just keep this first one the same. So the first one I'm going to keep is 6.2 times 10 to the 5th. This is going to stay the same. To make this a 10 to the 5th, I'm going to hop this decimal point over 1 and bring down minus 0.26 times 10 to the 5th. 4 to 5 is 1 hop. So all I'm going to do is 1 hop for that one. Now, if I'm going to make a 2 of 5, I can't just do 1 hop. 4 to 5 is just one single hop as you're moving that decimal point. Whereas to make to make this one a 5th power, that's going to be 3 hops. We're going to go to the 3rd, to the 4th, and then to the 5th. So we got to do 3 hops across. So I'm going to take this decimal point and I'm going to move it 1, 2, 3. Now remember, in those holders you got 0 that's going to hold in there. So I'm going to have to put 0, 0, 1, 9 times 10. And remember, I'm subtracting all the way across. So all I did is I just took this and hopped this. 1, 2, 3. And remember to make that, these are equal. These two things equal the exact same thing. They're the exact same amount. All I'm doing is hopping decimal points and changing the base power of 10. Anytime you hop a decimal point, all you're doing is multiplying or dividing by 10. It's super simple. Okay, my adding of scientific notation says that my answer is going to be 10 to the 5th, but I'm going to take 6.2 and I'm going to subtract 0.26 from that. So I'm going to do that subtraction first, and then I'll do the last subtraction at the end. Remember, you got to have a 0 that's within there. 0 minus 6 you can't do, so you're going to have to do some, we're going to have to do a little bit of borrowing. So 10 minus 6, or regrouping. 10 minus 6 is 4. 11 minus 2 is going to be 9. And then 5 minus 0 is going to give me 5. So my first subtraction gave me 5.94. 5.94, I still have to subtract off of that point 0.0019. All right, so remember, we're going to have to fill in some zeros there. And again, we're going to have to regroup. 0 minus 9 you cannot do. But I can take 10 minus 9. 10 minus 9 is 1. 9 minus 1 is going to give me 8. 3 minus 0 is going to give me 3. 9 minus 0 is going to give me 9. 5 minus 0 is going to give me 5. So my overall answer is 5.9381 once I do all the subtraction. Now, proper scientific notation, 1 digit in front of the decimal point. That's perfect. So I got 1 digit in front of the decimal point, exactly what you're supposed to have. So my answer overall will be 5.9381. 9381 times 10. And remember, I converted all these over to the fifth power. I did that conversion, and that conversion. So I got 5.9381 times 10 to the fifth power. Boy, that one was a tricky one. So here's what I'm also feeling like. I feel like when I give you guys some problems and I want you guys to like go and I want you to practice these problems, I feel like we don't always go back and review and make sure that we didn't have any questions. And so what I'm going to start doing is I'm going to start the beginning of every class. If you guys just want to chat with me through GoGuardian and tell me like you had a question on problem number 6. I will go through and do problem number 6 with you guys. We'll do it step by step together. That's just kind of how I'll begin my lesson. Know that all you guys are going to be doing on today's assignment is just going to be addition and subtraction. We'll just do a ton of practicing over addition and subtraction. We'll still stay in lesson 2.4 on Thursday, and I'm going to show you guys multiplication and division. I think multiplication and division might go a little bit easier for you guys. Tricky part might be just multiplying and dividing decimals. So we got to go back through and maybe review all of that. So the addition and subtraction piece of this one, the trickiest part, I think, is making sure each one of those is got the same base 10. So today what you guys will be doing is take a look in Google Classroom. You guys got an assignment that I need you to complete in there. After you do that Google assignment, I want you guys to go do 30 minutes of ST Math. So make sure you're getting your ST Math put in there. Make sure you guys are taking notes as well. So get those notes all taken care of. And then we'll come back, and on Thursday, I believe I'm with you guys again live. So on Thursday, I will go through multiplying and dividing, and then we might have to have some video recordings as well. So I'm kind of trying to meet everybody's needs here. So just communicating with me and let me know what works best for you is going to help me help you guys. So let me know if you guys have any questions. I'm here with you guys today. So reach out if needed. Good to see you guys. Chat with you soon. Bye.